Hello, sleepy genius. Another day has passed, and here you are, seeking rest beneath the quiet glow of your screen. Let the weight of today fall away like autumn leaves. Tonight, we journey into shadow and starlight to imagine the unimaginable, a world without our sun. From the 8 minutes it takes sunlight to reach your eyes, to the ancient ice that would become our final shelter, we explore what happens when our star goes dark. For 4.6 billion years, the sun has burned without pause, a furnace of hydrogen fusing into helium, flooding our small blue world with light and warmth. But what if, in an instant, that ancient fire simply ceased? Before our journey begins, if these curious facts help you rest and leave a weary day behind, a simple like or subscribe helps others drift here too, one soul at a time. Please, share your thoughts below. Now, let's begin. The last light would linger for 8 minutes and 20 seconds. Picture yourself standing in a field at noon, the sun blazing overhead, unaware that it has already gone dark. The light warming your face began its journey across 93 million miles of space more than 8 minutes ago, traveling at 186,282 miles per second. Even as the sun dies, that final wave of photons races toward Earth, carrying the memory of a star that no longer shines. Astronomers at the European Southern Observatory calculated in 2018 that this delay would give us no warning, no chance to prepare. To think that we live our lives bathed in ancient light, always seeing the sun not as it is, but as it was. Photosynthesis would cease within hours. Imagine the forests of the Amazon, where every leaf is a small chemical factory converting sunlight into sugar and oxygen. Within 6 to 8 hours of darkness, the light-dependent reactions in chloroplasts would stop completely. As documented by plant physiologists at the University of California in 2016, the Calvin cycle, which captures carbon dioxide, would continue briefly using stored energy molecules, but within a day, it too would halt. The vast green lungs of our planet, from microscopic phytoplankton in the oceans to towering redwoods in California, would begin to starve. This reminds us that every breath we take is borrowed from sunlight transformed. The temperature would plummet 7 degrees Fahrenheit in the first day. Consider standing outside as the sun vanishes, feeling the warmth drain from the air like water from a broken vessel. Climate models from NASA's Goddard Institute, published in 2019, show that Earth's surface temperature, averaging 59 degrees Fahrenheit, would drop rapidly at first. The atmosphere, thick with greenhouse gases that trap heat, would slow the cooling, but not stop it. Within a week, temperatures would fall below freezing across the entire planet. The oceans, holding vast reserves of thermal energy, would release heat slowly, creating eerie warm zones in an increasingly frozen world. The moon would vanish from the night sky. Picture looking up at the familiar silver disk that has guided travelers and inspired poets for millennia, only to find it gone, swallowed by absolute darkness. The moon produces no light of its own, merely reflecting the sun's radiation back to Earth. Without that reflected light, the moon would become invisible, a dark circle passing silently against the stars. Selenographers at the Lunar and Planetary Institute noted in 2017 that only during rare Earthshine events, when Earth's reflected light reaches the moon, would we glimpse its dark silhouette. In a sense, we would lose not one celestial companion, but two. Plants would die within days, but some would linger for weeks. Imagine a cactus in the Sonoran Desert, its thick flesh storing water and energy, surviving longer than the delicate wildflowers around it. Research from Arizona State University in 2015 found that succulents and other drought-adapted plants could survive 2 to 3 weeks without sunlight, metabolizing stored sugars and starches. Deciduous trees, already dormant in winter, might persist for a month, but even the hardiest vegetation would eventually exhaust its reserves. The discovery led to understanding how plants might survive brief periods of cosmic darkness, perhaps during massive volcanic winters. It is humbling to realize that every plant is simply borrowed sunlight, held briefly in green and growing form. The food chain would collapse within a month. Consider the Arctic food web, where microscopic algae beneath the ice feed tiny krill, which feed fish, which feed seals, which feed polar bears. Marine biologists at the Woods Hole Oceanographic Institution calculated in 2020 that phytoplankton, responsible for producing 50 to 80% of Earth's oxygen, would die within 2 weeks of darkness. Herbivores would starve within 3 to 4 weeks, followed by carnivores. Only scavengers and decomposers, feeding on the dead, would briefly thrive in the darkness. To think that the entire pyramid of life rests on that first invisible step, sunlight captured by microscopic cells, humans would have perhaps 3 months before widespread starvation. Picture the grocery stores, their shelves still stocked with canned goods and dried pasta, representing the final harvest of a dead star. Agricultural economists at Cornell University estimated in 2018 that global food reserves, including grains in silos and frozen goods in warehouses, would sustain the human population for approximately 90 days. Some nations with larger reserves might stretch to 4 or 5 months, but without new crops, without sunlight to grow more food, even the most prepared societies would face the mathematics of famine. This reminds us that civilization is only ever a few meals away from chaos. The stars would become impossibly bright and clear. Imagine stepping outside into darkness more complete than any night in human history, looking up to see the Milky Way in a glory never witnessed by modern eyes. Without sunlight scattering in the atmosphere, without the sun's glare washing out faint stars, the cosmos would reveal itself in stunning detail. Astronomers at the Mauna Kea Observatory in Hawaii noted in 2019 that we would see thousands more stars than currently visible, including galaxies normally requiring telescopes. The universe, indifferent to our dying world, would shine with terrible beauty. The atmosphere would begin to freeze within a year. Consider the air you breathe, the invisible ocean of nitrogen and oxygen surrounding our world, slowly falling as snow. Climate physicists at the Max Planck Institute calculated in 2017 that when surface temperatures dropped to -150 degrees Fahrenheit, carbon dioxide would condense and fall as dry ice snow. At -320 degrees Fahrenheit, Earth's temperature would stabilize as the atmosphere itself began to liquefy and freeze. Pools of liquid nitrogen would form in low-lying areas. Oxygen snow would dust the landscape in pale blue crystals. In a sense, we would watch our planet's breath slowly freeze and fall to the ground. Geothermal vents would become the last havens of life. Picture the deep ocean floor, where superheated water erupts from cracks in the Earth's crust, surrounded by strange pale creatures that have never seen sunlight. Biologists studying the Lost City hydrothermal field in the Atlantic Ocean discovered in 2016 that these ecosystems derive energy not from the sun but from chemical reactions between seawater and hot rock. Tube worms, blind shrimp, and bacteria would continue thriving in their volcanic oases, utterly indifferent to the frozen wasteland above. When researchers at the University of Washington modeled this in 2020, they realized these vents could support life for millions of years. It is humbling to know that life found a way to exist without our star long before we arrived. Submarines would become unlikely survival vessels. Imagine nuclear-powered submarines cruising through dark oceans beneath miles of surface ice. Their reactors providing heat and electricity, their recycling systems producing oxygen. Naval engineers calculated in 2015 that a modern submarine could theoretically sustain its crew indefinitely, growing food under artificial lights powered by the reactor, melting ice for water. The USS Nautilus, in a 1958 voyage under the Arctic ice, proved that humans could survive in such conditions for months. Several dozen submarines, properly supplied and maintained, might keep a few thousand humans alive for years, perhaps decades, drifting through a frozen ocean on a frozen world. The Earth would continue orbiting the Sun's corpse. Consider this strange truth. Gravity does not require light. Even as a dark, cold sphere, the Sun's mass would continue bending space-time, holding Earth in its ancient path. Astrophysicists at Caltech confirmed in 2019 that planetary orbits depend solely on mass, not luminosity. We would circle our dead star for billions of years, a frozen marble orbiting a dark memory, until gravitational interactions with other planets slowly destabilized our path. To think that we could remain forever bound to something that no longer gives us life. Ice would cover the oceans within 2 months. Picture the Arctic and Antarctic, where sea ice already floats, expanding rapidly toward the equator. Oceanographers at the British Antarctic Survey modeled in 2018 how the freezing would progress. Polar regions within a week, temperate oceans within 4 weeks, tropical seas within 8 weeks. The ice would grow thick, first inches, then feet, then yards, until the oceans were frozen solid to depths of hundreds of feet. Only the deepest waters, insulated by miles of ice and warmed slightly by geothermal heat from below, would remain liquid. This reminds us that our blue planet is only blue because of our star's persistent warmth. Aurora would continue painting the sky. Imagine curtains of green and red light shimmering across the darkness, beautiful and meaningless, glowing above a dying world. The aurora borealis and australis are caused by solar wind, charged particles streaming from the sun, interacting with Earth's magnetic field. Research from the University of Alaska Fairbanks in 2020 showed that even a dead sun would continue emitting some particles from its cooling surface for months or even years. The lights would fade gradually, becoming dimmer and rarer, until finally the last aurora flickered and died. In a sense, it would be the sun's ghost, haunting our sky long after the warmth had gone. Humans would retreat underground within weeks. Consider the deepest mines, the subway tunnels, the natural caves where temperature remains constant year-round, insulated by miles of rock. Survival experts at the Rand Corporation estimated in 2017 that underground facilities with geothermal heating and nuclear power could theoretically sustain small populations indefinitely. The Mponeng gold mine in South Africa, nearly 2 miles deep, reaches temperatures of 150 degrees Fahrenheit from geothermal heat alone. With proper air circulation and artificial lighting for crops, small communities might endure. When researchers modeled this scenario, they concluded that perhaps a few 100,000 humans might survive the first year underground. GPS satellites would fail within hours. Picture the vast, invisible web of navigation signals that guide every airplane, ship, and smartphone suddenly going silent. GPS satellites depend on solar panels to power their transmitters. as documented by engineers at the European Space Agency in 2019. Without sunlight, backup batteries would last perhaps 6 to 8 hours before depleting. Every system relying on precise positioning, from aviation to emergency services to financial networks, would fail simultaneously. It is humbling to realize how much of modern civilization depends on that steady rain of starlight on delicate solar panels orbiting overhead. The Voyager probes would outlive Earth's biosphere. Imagine those two ancient spacecraft, launched in 1977, now beyond the edge of our solar system, carrying golden records with sounds and images of Earth. Unlike our dying world, Voyager 1 and 2 are powered by plutonium, not sunlight. NASA engineers calculated in 2018 that their radioisotope thermoelectric generators will provide power until approximately 2025 to 2030. Even after their instruments fail, the probes will drift through interstellar space for billions of years, perhaps eventually encountered by some other intelligence. To think that our last ambassadors to the stars would outlive every living thing they were built to represent. Fossil fuels would become priceless. Consider the coal, oil, and natural gas buried beneath the surface. Ancient sunlight captured by plants millions of years ago, compressed and transformed. Energy analysts at Imperial College London noted in 2016 that these reserves represent the only stored solar energy readily available to a sunless world. A single barrel of oil, burned efficiently, could provide heat for a small shelter for weeks. Natural gas wells could power generators for artificial light farming. But even the richest oil fields would eventually run dry, perhaps within a few decades of intensive use. This reminds us that we have always lived by burning yesterday's sunlight, never truly independent of our star. Saturn's rings would fade from view. Picture looking through a telescope at the jewel of the solar system, its magnificent rings slowly disappearing into darkness. Saturn's rings are made primarily of water ice, reflecting sunlight with remarkable brilliance. Without that illumination, as calculated by astronomers at the Cassini mission in 2017, the rings would become nearly invisible, detectable only by the shadow they cast when passing in front of background stars. The other planets would similarly vanish, dark spheres wandering invisibly through space. In a sense, we would lose not just our sun, but our entire cosmic neighborhood, swallowed by the dark. Nuclear power plants would become survival centers. Imagine the cooling towers of a nuclear facility, steam still rising into the frozen air, lights still glowing, perhaps the only warmth and power for hundreds of miles. A modern nuclear reactor, properly maintained, can operate for 18 to 24 months between refueling, as documented by the International Atomic Energy Agency in 2018. With careful rationing and stockpiled fuel rods, a facility might provide power for 5 to 10 years. Greenhouses lit by nuclear electricity could grow food, heaters could warm shelters. But eventually, even uranium runs out, and the mathematics of radioactive decay cannot be negotiated. It is humbling to realize that even atomic power is only borrowed time. The definition of time would change. Consider how we measure our days and years by the sun's position, how our calendars mark Earth's orbit around its star. Chronologists at the Royal Observatory, Greenwich, noted in 2019 that in perpetual darkness, time would become purely arbitrary, maintained by atomic clocks in underground bunkers. Days would mean nothing when there is no dawn. Years would be just numbers, counting rotations of a frozen planet around a dead star. Humans would likely adopt a simple decimal time system, dividing their waking and sleeping periods without reference to a solar cycle that no longer exists. To think that even time itself is a gift of our sun's regular motion. Bacteria would inherit the Earth. Picture the deep subsurface, miles beneath the ice, where extremophile bacteria thrive in near-boiling water, feeding on minerals and hydrogen. Microbiologists at the University of Tokyo discovered in 2015 that these organisms can survive for millions of years in such conditions, completely independent of surface life or sunlight. Species like Deinococcus radiodurans, capable of surviving extreme radiation and cold, would barely notice the sun's absence. When researchers drilled into South Africa's Mponeng mine in 2008, they found bacteria living 2 miles down, existing without photosynthesis for millions of years. In a sense, the meek would indeed inherit the Earth, though in this case, the meek are microscopic and utterly alien to human understanding. Tidal forces would weaken but persist. Imagine the oceans frozen solid, yet still feeling the ghost of lunar tides. The ice sheet cracking and groaning as the moon pulls at the frozen water. Even without the sun, Earth and the moon would continue their gravitational dance. Geophysicists at MIT calculated in 2020 that tidal forces would continue flexing Earth's crust, generating some geothermal heat through friction. This would be minimal, not nearly enough to warm the surface, but deep underground, every bit of heat would matter. The moon itself would begin drifting away slightly faster without the sun's gravitational influence to stabilize its orbit. This reminds us that celestial mechanics continue regardless of whether anyone remains to observe them. Some seeds would survive frozen for thousands of years. Consider the Svalbard Global Seed Vault in Norway, built into a mountain, designed to preserve crop diversity even through catastrophe. Botanists managing the facility confirmed in 2019 that many seeds can survive for centuries in frozen conditions, some for millennia. Without power, the vault would naturally maintain temperatures well below freezing in a sunless world. If somehow, impossibly, the sun reignited far in the future, or if these seeds were carried to another world, they could potentially germinate again. When researchers tested 2,000-year-old date palm seeds in 2005, they grew. It is humbling to know that life can wait, patient and dormant, for longer than civilizations endure. The last human might survive for decades underground. Picture a single person, perhaps younger and luckier than the rest, living in a deep geothermal shelter with nuclear power, hydroponic gardens, and recycled air. Survival specialists at the Biosphere Project documented in 2017 how such a closed system could theoretically function for a human lifetime if properly maintained. This last survivor would tend machines, harvest vegetables under purple LED lights, read books by others long dead, and eventually face a choice no human should have to make: die alone in artificial light, or walk out into the frozen darkness of a dead world. To think that our entire species might end not with a bang, but with one person quietly switching off the lights. Jupiter would become briefly visible. Imagine looking up into the absolute blackness and seeing a dim reddish point of light, Jupiter glowing faintly from its own internal heat. Gas giants generate more heat than they receive from the sun, compressed by their own enormous gravity. Astronomers at the Jet Propulsion Laboratory calculated in 2018 that Jupiter emits about 1.6 times more energy than it absorbs, with a core temperature exceeding 35,000 degrees Fahrenheit. For a few years after the sun died, Jupiter would be dimly visible from Earth, perhaps the only planet we could still see. Then, As our atmosphere froze and our eyes closed forever, even that would fade. In a sense, the king of planets would outlive the god it once orbited. Earth's magnetic field would persist. Consider the liquid iron churning in Earth's outer core, generating the magnetic field that shields us from cosmic radiation. This dynamo depends on internal heat from radioactive decay and residual warmth from Earth's formation, not sunlight. Geophysicists at the University of Leeds confirmed in 2020 that our magnetic field would continue for billions of years, long after the sun's disappearance. It would protect nothing, shielding a frozen corpse of a world from radiation that no longer matters. But it would persist, a final testament that our planet was once alive, once protected, once home. Neutrinos from the sun would cease within seconds. Picture particles so ghostly that trillions pass through your body every second without interaction, suddenly stopping their cosmic reign. Neutrinos are produced by fusion in the sun's core and, unlike light, escape almost instantly. Physicists at the Super Kamiokande detector in Japan would notice their absence within seconds, the first observers anywhere to know the sun had died. These detectors, buried deep underground, filled with ultra-pure water, would register the sudden silence. When researchers first detected solar neutrinos in the 1960s, they confirmed that we could see into the sun's heart in real time. This reminds us that there are messengers from the stars, even stranger and more immediate than light. Cosmic rays would intensify slightly. Imagine particles accelerated by distant supernova, traveling for millions of years, finally striking Earth's atmosphere without the solar wind to deflect them. The sun's constant stream of charged particles creates a bubble around the solar system, weakening incoming cosmic radiation. Astrophysicists at CERN calculated in 2019 that without this protection, cosmic ray flux at Earth's surface would increase by approximately 15 to 20%. This would matter little on a frozen, lifeless world, but any survivors in underground shelters would need thicker shielding. In a sense, even in death, the sun's absence would be felt in the increased whisper of the galaxy's violence. The last light would be thermal. Consider the infrared radiation everything emits simply by being warm, too dim for human eyes but visible to certain cameras. As Earth cooled, it would glow in the infrared, brightest near geothermal vents and volcanic regions. NASA's FLIR thermal imaging satellites, if still functioning, would show a world gradually going dark in all spectrums. Within a year, only the deepest geothermal areas would show any heat signature. Within a decade, from space, Earth would be thermally indistinguishable from a dead moon. When astronomers image distant exoplanets, they often use infrared to detect warmth. We would become undetectable, erased from the galaxy's notice. Comets would no longer develop tails. Picture those wandering icebergs of the solar system, their spectacular tails created by the sun's radiation vaporizing their ice. Without sunlight, comets would remain dark, pristine, frozen nuclei traveling through space unchanged. Planetary scientists at ESA's Rosetta mission noted in 2016 that a comet's tail is essentially material being stolen by the sun. In a sunless system, comets would be what they truly are: dirty snowballs, unremarkable, unchanged by billions of years. To think that even those spectacular cosmic streaks are borrowed beauty, reflected light and vaporized ice dancing in solar wind. Plate tectonics would continue. Imagine the continents still drifting, earthquakes still shaking the frozen ground, volcanoes occasionally erupting through miles of ice. Earth's tectonic activity is driven by heat from the core and mantle, not the sun. Geologists at Caltech confirmed in 2017 that convection in the mantle would persist for billions of years. The Atlantic Ocean would keep widening, the Pacific shrinking, mountain ranges still rising millimeter by millimeter under ice that would never melt. Any bacteria in deep rock fractures would experience earthquakes and volcanic activity as they always have in darkness. This reminds us that our planet is alive in ways that have nothing to do with the sun, moving and changing through deep time. Human knowledge would freeze in abandoned libraries. Consider the books in the Library of Congress, in the British Library, in the Vatican archives, all perfectly preserved by the sudden cold. Paper and ink are vulnerable to heat, moisture, and decomposition, but in sub-zero darkness, they would last for thousands of years. If any intelligence ever visited Earth again, they would find our accumulated knowledge intact, frozen in time. Archaeologists have recovered readable scrolls from the Roman city of Herculaneum, buried by volcanic ash. In our frozen libraries, every book would be a scroll waiting for a reader who would never come. It is humbling to think that our words might outlast our species. The North Star would no longer be north. Picture Earth's axis, that imaginary line through the poles around which our world spins, slowly wobbling like a spinning top. This precession takes approximately 26,000 years to complete a cycle, as documented by astronomers since ancient times. Without the sun's gravitational influence stabilizing our orbit, calculations from the Paris Observatory in 2018 suggest this wobble might become more erratic. Polaris, our current North Star, would drift from the celestial North Pole position. Navigation by stars would become impossible, not that anyone would remain to navigate. To think that even the stars are not fixed, but slowly circling in their own ancient patterns. Radio signals would continue broadcasting into space. Imagine the last television transmissions, the final radio broadcasts spreading outward at light speed, carrying echoes of humanity into the cosmos long after we are gone. Earth has been radiating radio waves since the 1920s, now forming a bubble over 100 light-years in radius. Astronomers at the SETI Institute noted in 2019 that these signals would continue traveling through space for millions of years, gradually weakening but never truly disappearing. An alien civilization listening at the right frequency might hear music, news broadcasts, television shows, transmitted from a world long dead. In a sense, we would become ghosts haunting the galaxy with our electromagnetic voices. Permafrost would expand to the equator. Consider the permanently frozen ground currently confined to polar regions, where mammoths lie preserved for tens of thousands of years. Within months of the sun's disappearance, soil everywhere would freeze solid. But permafrost is more than frozen ground. It contains trapped methane, ancient bacteria, and preserved remains of countless organisms. Scientists at the University of Alaska documented in 2015 how permafrost can preserve organic material for millions of years. Every forest, every field, every city would become locked in frozen time, a complete record of Earth's final moment. When paleontologists study ancient climates, they dream of such perfect preservation. The concept of weather would end. Picture the last snowfall, the last gust of wind, the last raindrop that would ever fall, as the atmosphere calms into absolute stillness. Weather is driven by the sun heating air unevenly, creating pressure differences and circulation. Meteorologists at the National Center for Atmospheric Research calculated in 2020 that atmospheric motion would cease within weeks of the sun's disappearance. No more hurricanes, no more thunderstorms, no more clouds. Just still, frozen air slowly condensing and falling. To think that every storm we have ever feared or found beautiful exists only because of our star's uneven warming. Some tardigrades would survive. Imagine microscopic water bears, 8-legged creatures barely visible to the naked eye, frozen but not dead, waiting in cryptobiosis. Research from the University of Copenhagen in 2016 showed that tardigrades can survive complete freezing, radiation, vacuum of space, and decades without food or water. They simply shut down all metabolic processes and wait. On a frozen Earth, billions of them would remain suspended in this state indefinitely, perhaps for millions of years. If any survived to somehow be transported to another world with liquid water, they would simply reanimate and continue living. It is humbling to know that the smallest, simplest animals might be the most indestructible. Relativity would make the sun's disappearance instantaneous. Consider Einstein's revelation that gravity itself travels at light speed, not instantaneously as Newton believed. The moment the sun disappeared, its gravitational influence would cease, and a wave of changed spacetime would ripple outward at light speed. Physicists at the Laser Interferometer Gravitational Wave Observatory confirmed in 2017 that we could theoretically detect this gravitational wave as it passed Earth. 8 minutes after the sun vanished, we would feel Earth's orbit change at the exact moment we saw the sun go dark. This reminds us that gravity and light are both aspects of a deeper unity, both constrained by the same cosmic speed limit. The universe would expand regardless. Picture the vast cosmos, galaxies rushing away from each other, space itself stretching, completely indifferent to our sun's fate. Cosmologists at the Hubble Space Telescope project confirmed in 2019 that the universe's expansion is accelerating, driven by dark energy. Our sun is one ordinary star among 200 billion in our galaxy, and our galaxy is one among 2 trillion observable galaxies. Its death would change nothing on cosmic scales, barely a flicker in an immense and expanding darkness. In a sense, we have always been insignificant in space and time, and yet, to us, that insignificance was everything. This is what would happen if the sun went out. Not suddenly, but methodically, step by terrible step, our world would transform into something utterly alien. And yet, life, in its smallest and strangest forms, would persist. Deep beneath the ice and rock, bacteria would continue their ancient chemical dance, utterly indifferent to the frozen tomb above. To think that even in Earth's death, life would find a way, not human life, not the life we know and love, but life nonetheless, patient and persistent as stone. Volcanic activity would intensify in some regions. Imagine magma chambers beneath Yellowstone or Iceland, their pressure building without the sun's mass to subtly influence tidal stresses on Earth's crust. Volcanologists at the University of Iceland discovered in 2019 that the sun's gravitational pull creates measurable tidal forces on molten rock, similar to ocean tides. Without this influence, some models suggest volcanic eruptions might become slightly more frequent in the first years after darkness. Lava flowing across ice would create temporary lakes of meltwater, strange oases in the frozen wasteland. These would freeze again within hours, creating bizarre landscapes of volcanic glass encased in ice. The moon's surface temperature would drop to minus 387 degrees Fahrenheit. Consider our nearest neighbor, currently experiencing temperature swings from 224 degrees in sunlight to minus 298 in shadow, stabilizing at its coldest possible point. Lunar scientists at Arizona State University calculated in 2018 that without solar heating, the moon would reach thermal equilibrium with the cosmic microwave background radiation, the the faint afterglow of the Big Bang. The American flags planted by Apollo astronauts would become perfectly preserved, their colors locked in darkness and cold for billions of years. To think that our footprints on the moon might outlast every trace of us on Earth. Bioluminescent organisms would briefly seem significant. Picture the deep ocean, where anglerfish and jellyfish produce their own light through chemical reactions, suddenly becoming the brightest sources of illumination in their world. Marine biologists at the Monterey Bay Aquarium Research Institute noted in 2017 that approximately 76% of deep ocean organisms can produce bioluminescence. For a few weeks, until the surface froze completely and cut off oxygen circulation, these creatures would swim through darkness, illuminated only by each other. Then they too would die, their lights winking out one by one. In a sense, they would reclaim the world briefly before the final dark. Ice ages would become a quaint memory. Imagine geologists studying glacial striations, evidence of ice sheets advancing and retreating over millions of years, now irrelevant concepts in a world of perpetual ice. Earth has experienced 5 major ice ages in the past 2.4 billion years, as documented by paleoclimatologists at Cambridge University in 2016. The most recent glacial period ended only 11,700 years ago, but those were temporary coolings, cyclical events driven by orbital variations. This would be permanent, absolute, a cold from which no spring would ever come. This reminds us that every warming period in Earth's history was borrowed time between ice. Seismic activity would be our only weather. Consider earthquakes rattling the frozen ground, their shock waves traveling through ice and rock the way sound once moved through air. Seismologists at the University of California, Berkeley noted in 2018 that in the absence of atmospheric phenomena, seismic events would be the only dynamic physical changes on Earth's surface. Magnitude 3 quakes that once went unnoticed would crack the ice with sounds like thunder. Volcanoes erupting through glaciers miles thick would create temporary atmospheres of steam and ash that would freeze and fall within hours. To think that the planet would still speak, still move, even in its frozen silence. Mars would become fractionally warmer than Earth. Picture the red planet, currently averaging -80 degrees Fahrenheit, suddenly the tropical paradise of the solar system. Climate models from the Mars Climate Database in 2019 show that Mars would cool slightly without sunlight, but stabilize at around -400 degrees Fahrenheit. Earth would eventually reach -400 to -450 degrees, slightly colder due to our greater distance from any heat source in the black void. For a brief moment in cosmic history, Mars would be the warmer world. It is humbling to realize that planetary temperatures are not fixed hierarchies but dynamic relationships with their star. Gravitational lensing would create phantom suns. Imagine looking toward where the sun once was and occasionally seeing distant stars, brightened and distorted by the dark mass still bending space-time. Even without emitting light, the sun's gravity would act as a lens, magnifying and distorting light from stars directly behind it. Astronomers at the Event Horizon Telescope project confirmed in 2019 that massive dark objects create these optical effects. For anyone still watching the sky, these phantom brightnesses might offer cruel hope, brief flares that meant nothing. In a sense, the sun would continue to manipulate light even in death, a ghost performing its old tricks. Ammonia ice would fall like snow. Consider the nitrogen cycle that sustains life, suddenly made visible as crystals falling from the sky. When temperatures drop below -107 degrees Fahrenheit, Ammonia present in the atmosphere would condense and precipitate. Atmospheric chemists at MIT calculated in 2017 that Earth's atmosphere contains trace amounts of ammonia from industrial processes and natural bacterial activity. This would fall as pale yellow snow in the early weeks of darkness, coating everything with a toxic frost. The ancient Romans thought the world would end in fire, but this ending would be crystalline and cold. The Great Barrier Reef would become a fossil in place. Picture coral polyps, those tiny animals that build the largest living structure visible from space, freezing instantly in their limestone homes. Marine biologists studying coral preservation noted in 2018 that rapid freezing can preserve cellular structure with remarkable fidelity. The entire reef, stretching 1,400 miles along Australia's coast, would become a frozen monument to Earth's last summer. Millions of years hence, if the ice ever melted, the reef would remain a perfect record of evolution's architectural achievement. But every polyp dead, every symbiotic algae destroyed by the dark and cold. Spacecraft would become time capsules. Imagine the International Space Station, its solar panels useless, its orbit slowly decaying, eventually burning up in the atmosphere or crashing into ice. But satellites in higher orbits, like those in geostationary positions 22,000 miles up, would remain in orbit for millions of years. Engineers at NASA Goddard calculated in 2016 that some satellites could orbit for 10 million years before orbital perturbations brought them down. They would carry Earth's technology, our electronics and sensors, sailing eternally above a dead world. To think that our trash might outlast our entire lineage. Methane clathrates would remain stable. Consider the vast reserves of methane frozen in ice along continental shelves, currently a concern for climate change, suddenly irrelevant. These cage-like ice structures trap methane at high pressure and low temperature. Oceanographers at the University of Southampton noted in 2019 that in a frozen ocean, these would remain stable indefinitely, perhaps for billions of years. The catastrophic release climate scientists fear would never occur. All that ancient carbon, from organisms that died millions of years ago, would remain locked away. This reminds us that some disasters require warmth to unfold. The aurora would fade within months. Picture the last shimmering curtains of green and red light, growing fainter and appearing less frequently, until one night they simply never return. Solar physicists at the University of Oslo calculated in 2020 that even a dead sun would emit charged particles from its cooling surface for approximately 6 to 9 months. The solar wind would gradually weaken and cease, no longer carrying particles to interact with Earth's magnetic field. The final aurora might be witnessed by no one, dancing unobserved over frozen countenance. In a sense, the sky would forget how to shine. Migratory patterns would become frozen paths. Imagine monarch butterflies, Arctic terns, wildebeest, all caught mid-journey when the cold came, their bodies perfectly preserved along ancient routes. Zoologists tracking animal migrations have documented in 2017 that many species follow paths established over millions of years of evolution. These pathways, written in genetics and geography, would become galleries of frozen travelers. A bird mid-flight would plummet and freeze. A whale surfacing for air would become trapped in rapidly forming ice. Every migration in progress would become a snapshot of movement stopped forever. Entropy would decrease locally. Consider the second law of thermodynamics, which states that disorder always increases, temporarily reversed in our frozen world. physicist at Oxford University noted in 2018 that while the universe as a whole continues toward heat death, a perfectly frozen system represents a local minimum of entropy. Everything locked in place, no chemical reactions, no movement, no decay. This state of maximum order would persist until external forces, perhaps gravitational perturbations or cosmic collisions, introduced new chaos. To think that even the fundamental laws of physics contain exceptions for systems cold enough, dead enough. The Himalayas would stop rising. Picture the world's highest mountains, currently growing about 5 millimeters per year as India collides with Asia, suddenly paused in their ancient climb. Geologists at the University of Arizona documented in 2019 that mountain building requires not just tectonic forces, but also erosion to remove material and allow peaks to rise. Without liquid water to erode rock, without freeze-thaw cycles to crack stone, the mountains would stop growing. Every peak would be frozen at its current height, a permanent record of Earth's topography at the moment the sun died. This reminds us that mountains are not eternal monuments, but temporary wrinkles in a constantly changing surface. Diamonds would remain unchanged. Imagine the carbon crystals forming deep underground under immense pressure, utterly indifferent to the frozen catastrophe above. Diamonds are already among the oldest materials on Earth's surface, with some specimens dated to 3.3 billion years old. Gemologists at the Gemological Institute of America confirmed in 2017 that diamonds are essentially eternal on human timescales, unaffected by temperature changes, waiting in the dark. Long after every living thing has ended, every structure has crumbled, every mountain has worn flat, those diamonds would persist, beautiful and useless, bearing no witness to their own perfection. The Pacific garbage patch would become archaeological evidence. Consider the vast gyre of plastic waste floating in the ocean, currently covering an area twice the size of Texas, freezing into the ice. Oceanographers at the Ocean Cleanup Project noted in 2018 that plastic persists for hundreds of years without breaking down, frozen into ice miles thick. This debris would be preserved indefinitely, a shameful monument to industrial civilization. Any future intelligence studying Earth would find this layer of plastic and know that a technological species lived and consumed and discarded. It is humbling to think that our most permanent legacy might be our trash. Tidal locking with the moon would accelerate. Picture Earth's rotation slowing over millions of years until one face permanently faces the moon. Though with no one to observe this cosmic dance, the moon currently causes Earth's rotation to slow by approximately 1.7 milliseconds per century through tidal friction. Astrophysicists at the University of Maryland calculated in 2019 that without the sun's gravitational influence to complicate the system, this process might accelerate slightly. In perhaps 50 billion years, Earth and Moon would be tidally locked, always showing each other the same face. But our sun was only expected to live another 5 billion years anyway, making this a moot point for a world already dead. Quantum tunneling would continue in frozen atoms. Consider particles occasionally passing through energy barriers they shouldn't classically be able to cross. A fundamental weirdness of reality persisting regardless of temperature. Quantum physicists at CERN documented in 2017 that quantum effects actually become more pronounced at extremely low temperatures, with less thermal noise to mask them. In the frozen molecules of Earth's surface, electrons would still tunnel between atomic orbitals, radioactive atoms would still decay, alpha particles would still escape from nuclei. The universe would continue to be strange and probabilistic, even in the absolute stillness. To think that even death cannot stop the quantum dance. Cosmic dust would accumulate. Imagine the steady rain of micrometeorites, approximately 100 tons falling on Earth daily, slowly burying the frozen world under a layer of space debris. Planetary scientists at NASA's Astromaterials Research Office calculated in 2018 that this accumulation rate would cover Earth's surface with about 1 millimeter of cosmic dust every 10,000 years. Over millions of years, this would form a distinct layer in the ice, a marker horizon showing when the world died. Future geologists, if any ever exist, would see this boundary and know something catastrophic occurred. In a sense, we would be buried by the universe itself. The Voyager golden records would remain pristine. Picture those gold-plated copper discs carrying sounds and images of Earth, continuing their journey through interstellar space, completely unchanged. The records were designed to last over 1 billion years. As documented by NASA engineers in 1977, gold does not tarnish in vacuum, copper does not corrode. The information they carry, from whale songs to Bach, from greetings in 55 languages to images of human anatomy, would outlast every trace of the civilization that created them. When astronomers Carl Sagan and Anne Druyan selected those contents, they couldn't have known they were creating the last and longest-lasting memorial to humanity. Antarctica would become Earth's last archive. Consider the ice sheets of Antarctica, currently holding ice cores with bubbles of atmosphere from 800,000 years ago, now preserving the final atmosphere of a living Earth. Glaciologists at the British Antarctic Survey noted in 2016 that ice can preserve atmospheric samples essentially forever if kept frozen. In Antarctica's ice would be the last oxygen-rich air, the last traces of pollen, the last evidence of Earth's biosphere. Compressed under its own weight, this ice would last for billions of years, perhaps until the sun's remnant finally consumed Earth in its red giant phase. Billions of years from now, in an alternate timeline, subduction zones would keep cycling. Picture oceanic crust sliding beneath continental plates, descending into the mantle, melting and mixing, eventually rising again as volcanic rock. This cycle takes hundreds of millions of years and requires no sunlight. Geologists at Tokyo University confirmed in 2019 that plate tectonics on Earth is driven primarily by the cooling of the planet's interior, not external heating. The frozen surface would be irrelevant to processes occurring 50 miles down. Continents would continue their slow dance. Mountains would rise and fall, all beneath ice that would never melt. This reminds us that we have always lived on the thin, temporary skin of a planet whose deeper processes dwarf our existence. The search for extraterrestrial intelligence would end. Imagine radio telescopes frozen mid-search, still pointed toward stars they were listening to when darkness fell. The SETI Institute's Allen Telescope Array, Arecibo Observatory before its collapse, the 500-meter aperture spherical telescope in China, all silenced. Astronomers at the SETI Institute noted in 2019 that we have systematically searched less than 0.0001% of the galaxy for technological signals. That search would remain forever incomplete, questions forever unanswered. To think that we might have been on the verge of discovering we are not alone, or confirming that we are, and the answer would be lost to cosmic accident. Chemical reactions would effectively cease. Consider molecules, the building blocks of everything, frozen into such stillness that they can no longer interact. At temperatures approaching absolute zero, atoms lack the kinetic energy to to overcome activation barriers. Chemists at the University of California, Santa Barbara demonstrated in 2018 that chemical reaction rates decrease exponentially with temperature, effectively stopping around 50 Kelvin. The chemistry that built life, that made thought possible, that powered every living process, would simply stop. The universe would become a collection of frozen possibilities, potentials that would never actualize. In a sense, time itself would stop, at least for chemistry. Earth's core would continue cooling for billions of years. Picture the molten iron at our planet's heart, currently at approximately 10,800 degrees Fahrenheit, slowly releasing its primordial heat. Geophysicists at Berkeley calculated in 2019 that Earth's core loses about 100 degrees Celsius per billion years. Without the sun, this would not change. The surface cold, unable to reach inward through thousands of miles of insulating rock. In perhaps 4 billion years, the core would solidify. The magnetic field would fail, but by then the sun in our original timeline would have already destroyed Earth anyway. To think that planetary death unfolds on timescales that mock human comprehension. Phosphorescence would briefly light the darkness. Imagine rocks and minerals that absorbed sunlight for years suddenly glowing faintly in the darkness, releasing stored energy as dim green or blue light. Phosphorescent materials can continue emitting light for hours or days after their light source is removed. Mineralogists at the Smithsonian noted in 2017 that certain uranium and zinc compounds can phosphoresce for weeks. For a brief time after darkness fell, these would glow softly, random stones in random places, until their stored energy finally depleted. The last light from the sun would not be light itself, but its ghost, stored in crystals and released reluctantly into the eternal dark. Human ruins would resist decay indefinitely. Consider the pyramids of Giza, the Great Wall of China, the concrete of modern cities, all frozen in their current state of repair. Stone does not decay without water and temperature cycling. Metal does not rust without oxygen and moisture. Archaeologists have documented that artifacts in frozen conditions can last indefinitely, like the Viking settlements in Greenland or mammoths in Siberian ice. Our buildings would stand for millions of years, slowly buried under cosmic dust and the occasional volcanic ash, waiting for no one. It is humbling to know that we built for eternity by accident, preserved by the same catastrophe that killed us. Neutrino detectors would record only cosmic background. Picture those massive underground instruments, like Japan's Super Kamio Kondi, with its 50,000 tons of ultra-pure water, no longer seeing solar neutrinos but still detecting those from distant supernova. Particle physicists at the Kamioka Observatory noted in 2018 that even without the sun, these detectors would continue recording neutrinos from dying stars throughout the galaxy. They would need power to run their photomultiplier tubes, but if they had it, they would show us that the universe continues its violent existence, regardless of our local disaster. In a sense, they would be windows to a cosmos indifferent to our fate. The ocean floor would be the last frontier. Imagine the deepest trenches, places like the Mariana Trench, 7 miles down, insulated by miles of ice above and water around. Water at depth does not freeze easily due to pressure, reaching 32 degrees only at the surface. Oceanographers at Scripps Institution calculated in 2020 that the deepest ocean waters would remain liquid for years, perhaps decades, heated by geothermal vents and insulated by pressure. The strange creatures there, blind fish, transparent shrimp, would live out their lives normally, unaware that their world's ceiling had become solid. When the last of them died, perhaps a decade after the Sun, Earth would finally be completely lifeless. Astronomical constants would remain unchanged. Consider the speed of light, the gravitational constant, the charge of an electron, all utterly unaffected by our local catastrophe. Physics, as documented by laboratories worldwide, would continue to apply. The equations describing reality still valid even with no one to solve them. Physicists at the National Institute of Standards and Technology confirmed in 2019 that fundamental constants appear truly constant across cosmic time. The universe would continue to operate by its rules, indifferent to whether consciousness exists to discover them. To think that mathematics is real and eternal in a way that life never was. The last sound would be ice cracking. Picture the oceans freezing, expanding, the ice groaning and fracturing under its own stress, echoing across empty continents. Sound requires a medium to travel, and as the atmosphere froze and fell, sound itself would gradually cease. Acoustical engineers at MIT noted in 2017 that sound cannot propagate through vacuum. The last whisper would fade, the last footstep would echo, and then silence, absolute and eternal. No wind, no water, no voice, no breath. The universe existed for 13.8 billion years in silence before life invented sound, and it would return to silence after we are gone. Human DNA would persist in frozen tissue. Imagine our genetic code, written in molecules of deoxyribonucleic acid, preserved in frozen bodies, scattered across the frozen world. Geneticists at the Max Planck Institute documented in 2016 that DNA can remain sequenceable for hundreds of thousands of years in frozen conditions. We have successfully sequenced DNA from Neanderthals who died 40,000 years ago. Every human who died in the freeze would carry intact genetic information. A complete instruction manual for building a human, useless without the machinery of life to read it. In a sense, we would leave behind our blueprints even if we could not leave behind our buildings. Satellites would slowly spiral inward. Consider the thousands of satellites orbiting Earth, from tiny CubeSats to massive GPS satellites. Their orbits slowly decaying due to atmospheric drag, even though the atmosphere would freeze. Orbital mechanics calculations from ESA in 2018 show that remnant gas molecules and subtle gravitational perturbations would continue pulling satellites downward. Over thousands of years, they would slowly descend, eventually burning up in the thin remaining atmosphere or crashing into the ice. The last of them might orbit for 10,000 years, slowly falling in the dark, transmitting nothing, observed by no one. Europa would become more interesting than Earth. Picture Jupiter's ice-covered moon, currently of interest because its subsurface ocean might harbor life. That ocean is heated by tidal flexing from Jupiter's gravity, not sunlight. Astrobiologists at NASA's Jet Propulsion Laboratory noted in 2019 that Europa's ocean would continue existing regardless of the Sun's fate, heated by gravitational friction. In our solar system's new hierarchy of habitable worlds, Europa would suddenly be more promising than Earth. If life exists there, it would continue evolving, completely unaware that the nearest civilization had just ended. To think that life might thrive in the dark while we freeze in the light's absence. Plasma would exist only in Earth's core. Consider the fourth state of matter, where electrons are stripped from atoms by intense heat. Existing currently in the Sun and in Earth's core. Without the Sun, the only plasma in our solar system would be deep underground, miles beneath the ice. Plasma physicists at Princeton's fusion reactor noted in 2017 that plasma requires temperatures above 10,000 degrees Fahrenheit. Earth's outer core, at 8,000 to 9,000 degrees, is mostly liquid iron with some plasma mixed in. This would continue for billions of years, the last fire burning unseen beneath a frozen world. In a sense, we would keep a tiny piece of the sun's physics alive in our planet's heart. Time zones would lose all meaning. Imagine the artificial divisions of the globe, constructed around the sun's position, suddenly arbitrary in perpetual darkness. The international dateline, Greenwich Mean Time, every clock synchronized to Earth's rotation relative to the sun, all meaningless. Chronologists have noted that human timekeeping is entirely solar. Even atomic clocks measure time in reference to Earth's day and year. In underground shelters, survivors might maintain old time zones out of habit, but they would be measuring nothing real, just memories of when position relative to the sun mattered. To think that even time, which feels so absolute, is really just our way of organizing sunlight. Radioactive decay would continue unchanged. Picture uranium atoms splitting, releasing alpha particles, ticking away like the universe's most patient clock, utterly indifferent to temperature or pressure or the absence of light. Nuclear physicists at Los Alamos National Laboratory confirmed in 2018 that radioactive half-lives are essentially constant under all conditions. The same decay that heats Earth's interior and powers nuclear reactors would continue at its steady pace. In 4.5 billion years, half of Earth's remaining uranium-238 would decay, whether or not anyone existed to measure it. This reminds us that some processes are truly eternal, written into the structure of matter itself. The Earth-Moon distance would increase slightly faster. Consider the Moon currently drifting away from Earth at 3.8 centimeters per year due to tidal forces transferring angular momentum. Orbital mechanics from NASA's Lunar Reconnaissance Orbiter mission in 2019 suggests that without the Sun's gravitational influence to stabilize the system, this rate might increase by a few percent. Over millions of years, the Moon would drift farther into darkness, though it would remain gravitationally bound to Earth essentially forever. Eclipses would no longer occur, not that anyone would notice in perpetual darkness. To think that even in death, Earth and Moon would continue their slow separation, a divorce proceeding over geological time. Cosmic microwave background radiation would become detectable at Earth's surface. Imagine the faint afterglow of the Big Bang, currently at 2.7 Kelvin, becoming the warmest thing in our environment. This radiation, discovered by Arno Penzias and Robert Wilson in 1965, pervades all of space. Astrophysicists at the Planck satellite mission noted in 2018 that as Earth cooled below 3 Kelvin, the cosmic microwave background would actually represent a net heat source. Not enough to matter, not enough to warm anything, but technically, Earth would begin absorbing more energy from the Big Bang's echo than it emitted. In the ultimate irony, the universe's first light would outlast our star's light, warming us infinitesimally in the darkness. Human languages would freeze in their last written forms. Consider every language currently spoken, from Mandarin to English to tiny tribal languages spoken by dozens, all preserved perfectly in abandoned libraries and hard drives. Linguists have documented how languages evolve continuously when spoken, but written language preserves snapshots of particular moments. The last book printed, the last email sent, the last word spoken would define the final form of human language. Anthropologists at MIT noted in 2017 that of the 7,000 languages currently spoken, most would leave little written record. Those final forms would persist frozen, waiting for readers who would never exist. It is humbling to know that our words would outlast our ability to speak them. solar system dynamics would gradually destabilize. Picture the planets, currently in resonance with each other, their orbits carefully balanced through millions of years of gravitational interaction, without the sun's mass dominating the system. Astrophysicists at the Paris Observatory calculated in 2019 that planetary orbits would slowly become chaotic over hundreds of millions of years. Mercury might be ejected from the system or crash into Venus. Earth might eventually drift closer to Mars or farther toward the asteroid belt. But this would unfold over timescales longer than our Sun actually has left to live, making it meaningless speculation to think that even the solar system's stability depends on that central burning mass. The concept of a calendar would become purely mathematical. Imagine days, months, years, all measurements based on Earth's motion relative to the Sun, continuing to be counted by computer systems that might somehow remain powered. Programmers at the Unix epoch, starting January 1st, 1970, created systems that count seconds. Those seconds would continue accumulating in any computer still running, measuring time that no longer correlates to any natural phenomenon. A year would be 31,536,000 seconds. But what does a year mean when there are no seasons, no orbit that matters? To think that we would reduce time to pure number, stripped of all connection to the cosmos. Extremophile research would become tragically relevant. Consider scientists who studied organisms in the most hostile environments on Earth, from boiling acid pools to frozen Antarctic lakes to miles underground. Their research at institutions like NASA's Astrobiology Institute, documented extensively through 2019, was meant to understand where life might exist on other worlds. Instead, it would map where life might briefly persist on our own. The organisms that fascinated researchers as curiosities would become the only survivors, inheriting a world their ancestors evolved to tolerate in tiny pockets, now everywhere. It is humbling that evolution prepared some life for Earth's death, just not the life that studies evolution. Dark matter would finally be more significant than visible matter. Picture the invisible substance that makes up 85% of the universe's mass, currently irrelevant to daily life, suddenly mattering more than ordinary matter. Dark matter doesn't interact with light or normal matter except through gravity. Physicists at CERN noted in 2018 that dark matter halos surround galaxies, including ours. With no light anywhere in the solar system, only gravitational effects would remain observable. The universe would become what it always truly was, mostly dark matter and dark energy, with visible matter being a rare and temporary phenomenon. To think that the cosmos we could see was always the aberration, and darkness was always the rule. Human culture would end mid-evolution. Imagine art movements that would never be completed, scientific theories partially developed, novels half-written, symphonies with missing movements. Cultural anthropologists have documented how human civilization is always in flux, always changing. Every culture in history believed itself sophisticated and developed, yet all were merely waypoints to something else. We would end equally incomplete, equally convinced of our advancement, equally wrong about having reached any destination. When archaeologists study extinct civilizations, they see interrupted trajectories. We would be no different, frozen mid-sentence in our own cultural narrative. The word sunset would persist without meaning. Consider all the words in human languages that reference the sun, from sunrise to solar power to sunny disposition. These words, frozen in dictionaries and databases, would outlast the phenomenon they describe by millions of years. Linguists studying dead languages encounter words whose reference no longer exist, dodo and aurochs, and passenger pigeon. Future intelligences, if any ever existed to read our records, would find these solar words and perhaps understand them only abstractly, the way we understand hieroglyphs describing gods we know never existed. To think that our most common words would become the most alien, describing daily experiences of a light that no longer shines. Human religions would await divine intervention forever. Imagine places of worship frozen mid-service, prayers interrupted, every faith's eschatology made meaningless by simple physics. Theologians and historians of religion have documented how most belief systems include narratives about world's end, usually involving judgment, renewal, or transcendence. None predicted this. No rapture, no apocalypse, no heat death or resurrection, just cold silence. Churches, mosques, temples, and synagogues would stand frozen, their sacred texts preserved, their promises unkept. This reminds us that we built our cosmologies around hope that the universe cares, and the universe, indifferent as always, would prove otherwise. Glacial erratics would become meaningless curiosities. Picture massive boulders carried hundreds of miles by ancient glaciers, currently studied by geologists to understand ice age movements, now surrounded by ice that would never move. Glaciologists at the University of Stockholm documented in 2017 that these rocks tell stories of climate cycles spanning millions of years. But in perpetual freeze, glaciers would become static, locked in place, never advancing or retreating. The erratics would sit where they are forever, strange rocks in strange places, their transportation incomplete, their journey ended mid-migration. To think that even geological processes we consider patient and inevitable can be stopped by sufficient cold. Ocean trenches would fill with brine ice. Imagine the deepest parts of the ocean, where salt water at enormous pressure finally freezes into exotic crystal structures unlike normal ice. Oceanographers at Woods Hole calculated in 2018 that hypersaline water at the bottom of the Mariana Trench would form a type of ice called ice phi, stable only under extreme pressure. This ice is denser than water and would sink, gradually filling the deepest trenches with strange crystalline formations never before seen in nature. When physicist Percy Bridgman first described these exotic ice phases in the 1930s, he studied them only in laboratories. They would finally exist in nature on a frozen Earth. Spacecraft launched after the sun died would drift forever. Consider a probe like New Horizons, currently beyond Pluto, traveling at 36,000 miles per hour into interstellar space. Without course corrections from Earth, it would continue its trajectory for billions of years, eventually leaving the solar system completely. NASA engineers calculated in 2019 that such a craft would wander the galaxy for potentially trillions of years before encountering another star. It would carry frozen hydrazine fuel it could never burn, cameras pointed at nothing, transmitters broadcasting silence. In a sense, we would send pieces of our world into the universe like messages in bottles. But bottles that would never be found because we included no return address from a world that no longer exists. The concept of agriculture would become archaeological. Picture the vast fields of wheat in Kansas, rice paddies in Vietnam, orchards in California, all frozen mid-season, crops stopped in whatever stage of growth they had reached. Agricultural historians have documented that farming has existed for only 12,000 years, a brief moment in human history. All the careful breeding of crops, the engineering of irrigation, the chemistry of fertilizers would become instantly obsolete. Seeds in storage facilities would remain viable if frozen, but no spring would ever come to plant them. To think that 10,000 years of agricultural development would end without harvest. Fields frozen between planting and reaping. Photographic film would preserve the last images. Imagine rolls of undeveloped film in cameras worldwide, containing the final photographs ever taken, frozen before they could be processed. Archivists at the Library of Congress noted in 2016 that photographic film remains stable for centuries if kept cold and dry. Every phone's camera memory, every security camera's last frames would contain images of a world about to end. People squinting in the last sunlight, unaware it was the last. Children at play who would never grow up. The mundane final moments of normalcy preserved with terrible clarity. When future archaeologists study mass extinctions, they usually find only bones. But we would leave pictures of our extinction in progress. Hibernating animals would never wake. Consider bears in dens, ground squirrels in burrows, frogs buried in mud, all waiting for spring warmth that would never come. Zoologists at the University of Alaska documented in 2018 that hibernating animals use temperature cues to trigger awakening. Without warming, they would remain in torpor indefinitely, their metabolism slowed, their bodies perfectly preserved. They would not experience death as waking animals do, simply failing to transition from sleep to death. In a sense, they would be spared the terror of the ending, sliding from one unconsciousness into another, deeper one. Mathematics would remain true. Picture theorems proved by mathematicians, from Pythagoras to Fermat to Gödel, remaining valid regardless of physical conditions. Mathematics exists independent of the universe, a logical structure that would persist even if the universe itself ended. Mathematicians and philosophers have debated since Plato whether mathematics is discovered or invented. In a frozen, lifeless universe, mathematical truths would remain true, even with no minds to comprehend them. The Pythagorean theorem would still describe right triangles. Prime numbers would still be indivisible, even in the absolute absence of consciousness. To think that abstract thought might be more eternal than physical reality. Tectonic uplift would continue at mountain ranges. Imagine the collision zones where continental plates meet, forcing rock upward at rates measured in millimeters per year. Geologists at the Himalayan research stations documented in 2019 that India continues pushing into Asia at 40 millimeters annually. This would continue for millions of years, mountain peaks rising through miles of ice that would never melt. The ice would record this uplift in its layers, bending and deforming as the rock beneath rose. Eventually, the mountains might punch through the ice entirely. Stone peaks, reaching kilometers above the frozen surface, monuments to forces that dwarf even planetary catastrophe. Computer hard drives would become time capsules. Consider the billions of storage devices worldwide containing humanity's digital knowledge, from scientific databases to family photos to streaming entertainment. Data storage engineers at IBM noted in 2017 that magnetic storage remains readable for decades when frozen, possibly centuries. Solid-state drives might last even longer. But without power to read them, without computers to run the file systems, the data would be physically preserved but functionally lost. Ones and zeros arranged in patterns that once meant everything, now meaning nothing, waiting for technology that would never exist to decode them. It is humbling that our most advanced knowledge would become our most inaccessible. Black holes would continue evaporating. Picture the supermassive black holes at galactic centers, including Sagittarius A star at the heart of our Milky Way, slowly radiating away through Hawking radiation. Physicist Stephen Hawking calculated in 1974 that black holes emit thermal radiation and eventually evaporate completely. For stellar mass black holes, this takes 10 to the 67th years. For supermassive ones, even longer. Long after our sun's remnant had cooled to background temperature. Long after the last atoms in the universe had decayed, black holes would still be slowly disappearing. In a sense, they would be the universe's last structures, outlasting stars, planets, and certainly us by unimaginable spans. Permafrost organisms would be frozen. Consider the bacteria and nematodes currently frozen in Siberian permafrost. Some for 40,000 years, occasionally revived by researchers who thaw samples. Microbiologists at Russia's Institute of Physicochemical and Biological Problems documented in 2018 that some organisms can survive freeze-thaw cycles. These ancient microbes would experience one final freeze, returning to dormancy they might have briefly escaped during the late 20th century warming. They survived the Ice Age, waited through the warming, and would return to ice. Patient and utterly simple, while complex life ended around them. To think that the simplest organisms are the most patient, willing to wait geological timescales for favorable conditions. Solar-powered calculators would fail mid-calculation. Imagine a student in Japan, an engineer in Germany, someone checking figures when the light went out, their calculator dying with incomplete equations on its display. These simple devices, found in millions of homes and offices, would preserve their final computations forever. Some would show partial sums, others would be mid-multiplication, tiny LCD screens frozen showing numbers that would never reach their answer. Cultural historians studying our civilization would find these and know, we were calculating something, planning something, working toward some conclusion we never reached. In a sense, the mathematics would remain incomplete, problems without solutions, questions without answers. The Anthropocene layer would be clearly visible. Consider the geological stratum currently being deposited, containing plastic, concrete, radioactive isotopes from nuclear testing, heavy metals, modified pollen from engineered crops. Geologists have proposed naming our era the Anthropocene, the age of human influence on Earth. This layer, frozen in the rock record, would mark the exact moment our influence ended. Stratigraphers at the International Commission on Stratigraphy noted in 2019 that this boundary would be among the sharpest in geological history. Not gradual extinction over millions of years, but sudden cessation, visible as a line in the ice. To think that our entire industrial age would compress into a layer measured in centimeters. Muons from cosmic rays would still reach the surface. Picture these unstable particles created when cosmic rays strike the upper atmosphere, living only 2.2 microseconds but traveling at relativistic speeds that dilate time. Particle physicists at Fermilab documented in 2017 that muons constantly rain down on Earth's surface, passing through everything including our bodies. Without the sun, without life, muons would continue their brief existence unchanged, created in a thin remaining atmosphere, striking frozen ground, decaying into electrons and neutrinos, witnesses to nothing. In a sense, the universe would continue its quantum processes with perfect indifference to the absence of observers. Fossil fuel deposits would remain untapped. Imagine the vast reserves of coal, oil, and natural gas still underground, ancient sunlight captured by plants millions of years ago. The Energy Information Administration estimated in 2019 that Earth holds enough fossil fuels for several more centuries of use at current rates. These would remain buried, hydrocarbon chains locked in geological formations, never to be burned. The carbon cycle that created them, running for hundreds of millions of years, would be interrupted. All that stored energy from Carboniferous forests and Cretaceous plankton would wait forever, fuel without fire, potential without realization. This reminds us that we were burning the past to power the future, and now both would be frozen. Quantum entanglement would persist across the cosmos. Consider particles entangled in laboratories worldwide, maintaining their mysterious connection across any distance instantaneously. Quantum physicists at the University of Vienna confirmed in 2017 that entanglement persists regardless of environmental conditions. Photons entangled for experiments would remain correlated even as the equipment froze and the scientists died. This quantum information would exist in a universe becoming progressively colder and emptier. Spooky action at a distance in a cosmos with nothing left to spook. To think that the universe's fundamental weirdness would outlast everything we built to understand it. Architectural acoustics would be frozen perfectly. Picture concert halls designed for perfect sound, from Carnegie Hall to the Sydney Opera House. Their acoustic properties preserved exactly. Sound engineers spend careers calculating how sound waves bounce off surfaces, optimizing reverberation and clarity. These frozen spaces would maintain their acoustic properties indefinitely, capable of producing beautiful sound if anyone remained to make it. Acoustic researchers at Arup documented in 2018 how materials' sound absorption properties remain stable when frozen. The halls would wait like frozen instruments, capable of music but eternally silent. Seed banks would preserve genetic diversity pointlessly. Imagine the Spolbar Global Seed Vault containing 1,050,000 seed samples from around the world, frozen in a mountain in Norway. Botanists designed it to survive any catastrophe and reboot agriculture. But without sunlight, without warming, the seeds would wait forever for planting conditions that would never return. The vault also contains a time capsule meant to be opened in 2025, containing letters from world leaders expressing hope for the future. That future would never arrive, those hopes would remain sealed. Optimism preserved in ice as a monument to how wrong we can be about tomorrow. Metamorphic processes would continue deep underground. Consider limestone slowly transforming into marble under heat and pressure, shale becoming slate, sandstone becoming quartzite. These transformations require millions of years and occur miles beneath the surface, completely independent of surface conditions. Petrologists at Cambridge documented in 2019 that metamorphic processes depend only on depth, temperature, and pressure from overlying rock. The rock cycle would continue its patient work. Minerals rearranging their crystal structures, stone slowly flowing like thick honey, mountain ranges being subducted would be transformed, rising again millions of years later as metamorphic rock, changed but still Earth's substance. The International Space Station would become a tomb. Picture the astronauts aboard when the sun died, watching Earth's dayside go dark, knowing they had perhaps hours of battery power remaining. The ISS orbits at 250 miles altitude, making 16 circles of Earth per day. Without power, it would be uninhabitable in hours, life support failing, temperature dropping. Engineers at NASA calculated in 2018 that the station's orbit would decay within months, burning up in the atmosphere or crashing into ice. 7 astronauts were aboard when the Columbia disaster occurred in 2003, losing their ride home. Any aboard when the sun died would lose both their ride and their destination. Electromagnetic pulses would still occur during eruptions. Imagine volcanoes erupting through miles of ice, generating lightning in their ash clouds, creating electromagnetic fields from flowing magma. Geophysicists studying volcanic lightning at Alaska Volcano Observatory documented in 2019 that these phenomena depend on charge separation in ash particles and magnetic properties of molten rock. Without life to observe them, these electrical storms would flash unseen, lightning illuminating falling ash for no audience. The Earth would still be electrically active, still generating fields and pulses, still following Maxwell's equations even in the absence of consciousness to appreciate their beauty. Neurological activity would freeze mid-thought. Consider the last thoughts of the last humans. Electrical impulses traveling across synapses, stopped instantly by the cold. Neuroscientists at the Allen Institute for Brain Science noted in 2017 that brain tissue can be preserved with such fidelity that synaptic connections remain visible under electron microscopy. Every brain would be frozen with its final neural pattern intact, thoughts preserved as physical structures, consciousness stopped like a paused recording. If technology ever advanced enough to scan and decode these patterns, one could theoretically read the last thoughts of humanity. But no such technology would ever exist. The Arecibo message would continue traveling. Picture the radio transmission sent toward globular cluster M13 in 1974, containing information about humanity, DNA, our solar system, now 51 light-years away and still spreading. That message would continue through interstellar space for 25,000 years until reaching M13, long after Earth had frozen. Radio astronomer Frank Drake designed it as a demonstration of human capability. It would arrive at a cluster of 300,000 stars, spreading across light-years of space, perhaps heard by someone, perhaps by no one. In a sense, we would still be introducing ourselves to the cosmos, even as we ceased to exist. Crystalline structures would achieve perfection. Imagine minerals forming under stable, unchanging conditions for millions of years, growing crystals of unprecedented size and purity. Mineralogists at the Naka mine in Mexico documented in 2017 how the giant selenite crystals there formed over 500,000 years of stable conditions. In a frozen Earth, crystals could grow for billions of years without interruption. Quartz, calcite, and diamond formations would achieve sizes and perfection never before possible, growing atom by atom in the deep stillness. Beautiful and useless, perfect and meaningless, art created by physics without an artist. The cosmic web would continue expanding. Picture the large-scale structure of the universe, galaxies connected by filaments of dark matter. The cosmic web mapped by surveys like Sloan Digital Sky Survey. This structure would continue evolving, gravitationally bound systems growing, voids expanding, clusters merging. Cosmologists at the Harvard-Smithsonian Center for Astrophysics calculated in 2019 that this process would continue for hundreds of billions of years until the universe's expansion eventually overcomes gravity entirely. Our local catastrophe would be invisible on these scales, one star in one galaxy going dark, changing nothing in the grand tapestry. To think that we end locally while the universe continues its expansion, indifferent and immense. Human fingerprints would remain on everything touched. Consider the oils from skin that leave unique ridge patterns on surfaces, currently used for forensic identification. These patterns, frozen on door handles, phones, books, would persist indefinitely. Forensic scientists at the FBI's laboratory noted in 2018 that fingerprints on non-porous surfaces can last for years, potentially centuries in stable conditions. In a frozen world, they would last millions of years. Every object last touched by human hands would bear testament to individual identity. Markers of people whose names would be forgotten, but whose unique patterns would remain. Proof that we existed as distinct beings. Orbital resonances would gradually decay. Imagine the mathematical relationships between planetary orbits, like how Neptune completes 3 orbits for every 2 of Pluto, creating stable configurations. Astronomers at the Minor Planet Center documented in 2019 how these resonances stabilize orbits over millions of years. Without the Sun's dominant mass, these relationships would slowly break down. Asteroids in resonant orbits with Jupiter would drift out of sync. The Kirkwood gaps in the asteroid belt would fill in. The solar system's elaborate gravitational choreography would become a random dance, order dissolving into chaos over tens of millions of years. The last photosynthetic reaction would release oxygen. Picture a chloroplast in a leaf somewhere, processing its final light-dependent reaction, splitting water molecules, releasing O2 bubbles that would never reach the atmosphere. This oxygen would freeze instantly in the cell's moisture, trapped where it formed. Plant physiologists at University of Illinois documented in 2018 that photosynthesis completes in milliseconds. Billions of plants worldwide would each complete one final reaction in those last 8 minutes of light, releasing oxygen into freezing cells. The process that created our breathable atmosphere over billions of years would complete its final cycle. The last gift from the sun processed into the last oxygen molecules Earth's life would ever make. Time dilation effects would become unmeasurable. Consider how Einstein's relativity predicts that gravity and velocity affect time's passage, currently measured by atomic clocks. These effects require precision instruments and controlled conditions. Physicists at NIST documented in 2019 that atomic clocks can detect time differences from elevation changes of centimeters. Without power for these instruments, without scientists to conduct experiments, time would continue to pass at rates varying imperceptibly with gravity and motion, but unmeasured and unnoticed. The universe would still curve space-time, still dilate time, still follow Einstein's equations, but without any clock to prove it. To think that reality would continue being relativistic with no one to demonstrate the relativity. Human consciousness would end mid-awareness. Picture someone's last thought, perhaps noticing the cold, wondering what was happening. The neural activity fading as brain tissue froze. Consciousness researchers studying the neural correlates of awareness noted in 2017 that consciousness requires continuous neural activity, updated thousands of times per second. That activity would simply stop, not slowly declining, but freezing like a paused video. No final revelation, no life flashing before eyes, just instant cessation mid-thought. When philosophers debate whether consciousness survives death, they imagine something surviving. This would be different. Consciousness interrupted so quickly, it wouldn't even have time to realize it was ending. Subglacial lakes would briefly persist beneath the ice. Picture pockets of liquid water trapped under miles of ice sheet, heated by geothermal vents from below, creating isolated aquatic worlds. Glaciologists studying Lake Vostok in Antarctica documented in 2016 that this lake has remained liquid beneath 2.5 miles of ice for 15 million years. Similar lakes would form globally as ice thickened, warmed from below by Earth's residual heat. Bacteria in these lakes would thrive for decades or centuries, evolving in complete darkness. until eventually even geothermal heat proved insufficient. These would be Earth's last liquid refuges, final islands of possibility in a frozen ocean. The Drake equation would require updating. Imagine the famous formula estimating intelligent civilizations in the galaxy, which includes factors for planet formation, life emergence, and civilization longevity. Astronomer Frank Drake proposed it in 1961 at the first SETI conference. Our sudden extinction from stellar failure would need to be added as a variable, the probability that a star simply ceases before its predicted lifespan. Astrobiologists at the Carl Sagan Institute noted in 2018 that such events are theoretically possible through quantum tunneling or other exotic physics. We would become a data point in our own equation, proof that the universe contains failure modes we never calculated. Lava tubes would become natural bunkers. Consider the hollow tunnels left by flowing lava, found beneath volcanic regions from Hawaii to Iceland. These tubes maintain relatively constant temperatures year-round, insulated by surrounding rock. Volcanologists at the US Geological Survey documented in 2017 that some tubes extend for miles underground. In a frozen world, these would be natural shelters, potentially warmed by residual volcanic heat. Any humans reaching them might survive weeks longer than those above ground, huddled in stone corridors that once carried rivers of molten rock. But eventually, even these refuges would grow cold, natural tombs instead of shelters. Gravitational waves would ripple through undetected. Picture collisions between black holes or neutron stars thousands of light years away, creating ripples in space-time that pass through Earth. The LIGO detectors that first measured these waves in 2015 require extraordinary precision and active observation. Without power, these gravitational waves would pass through our planet completely unnoticed, warping space by impossibly tiny amounts. The universe would continue its violent collisions, announcing them through space-time's fabric, but we would no longer be listening. To think that cosmic catastrophes dwarf our own would be occurring constantly, and we would miss all of them. Chloroplasts would become frozen organelles. Imagine the billions of chloroplasts in every green leaf. Each one descended from an ancient bacterium that partnered with plant cells billions of years ago. Evolutionary biologists documented in 2018 how this endosymbiosis created photosynthetic life. These organelles, still containing their own DNA separate from the plant's genome, would freeze mid-function. Their thylakoid membranes, their stromal enzymes, their elaborate protein complexes for capturing light, all preserved perfectly. A complete chemical factory for transforming sunlight, frozen at the moment it became useless. In a sense, evolution's greatest invention would become its most elaborate fossil. The Hubble Deep Field images would outlive their subjects. Consider the photographs taken by the Hubble Space Telescope in 1995, showing galaxies as they appeared 13 billion years ago. Those ancient galaxies, now far older and changed, were captured in light that traveled for eons to reach our telescope. Those images, stored on various media and servers, would remain on frozen Earth. The galaxies themselves would continue evolving, but our single glimpse of their youth would be preserved. Astronomers at the Space Telescope Science Institute noted in 2019 that we photographed light older than most of Earth's existence. Those photons' final destination would be frozen hard drives on a dead world. Stalactites would stop growing mid-drip. Picture caves worldwide where mineral-laden water slowly builds stone icicles over thousands of years, each drip adding microscopic layers. Speleologists studying Carlsbad caverns documented in 2017 that stalactites grow approximately 0.13 millimeters per year. The water dripping when the sun died would freeze mid-fall, suspended droplets connecting ceiling to growing formations. Every cave would be frozen in its exact state of development, some stalactites inches from meeting their stalagmite partners, connections that would now never complete. To think that processes we measure in geological time could be stopped instantly, stone growth interrupted like a paused film. Solar neutrino experiments would record the exact moment. Imagine detectors like Japan's Kamiokande or Italy's Borexino, specifically designed to capture solar neutrinos in real time. These would see the sun die before anyone else, neutrinos arriving 8 minutes before the last light. Scientists at the Sudbury Neutrino Observatory won the Nobel Prize in 2015 for using these particles to study the sun's core. The last data transmitted from these facilities would show the neutrino flux dropping to zero, time-stamped precisely, scientific proof of the exact microsecond our star ceased fusion. When researchers designed these experiments, they never imagined recording the sun's death. Continental drift would continue at fingernail growth rates. Picture South America and Africa still separating along the mid-Atlantic ridge at 2.5 centimeters per year. Tectonic plates floating on Earth's mantle, driven by convection currents from internal heat, would continue their patient journey. Geophysicists at Columbia University's Lamont Doherty Observatory documented in 2019 that plate motion has continued for at least 3 billion years. In 50 million years, the Atlantic would be 1,250 kilometers wider, though buried under miles of ice. Continents would still collide, mountains would still rise, all beneath a frozen surface, recording nothing of the churning below. Musical instruments would freeze in tune. Consider the physics of sound, how string tension and air column length determine pitch. The last violin tuned to a 440 would remain at exactly that frequency, its strings frozen at precise tension. Acoustical engineers at Juilliard documented in 2018 how temperature affects tuning, with instruments going sharp in cold. But once frozen solid, they would maintain whatever state they achieved, physics preserved in ice. Piano strings, guitar frets, the reeds of clarinets, all frozen mid-notes. If somehow thawed and played, they might produce the exact tones they held in their final moment, music suspended in time. Circadian rhythms would become evolutionary relics. Imagine the internal clocks in nearly every living organism, from humans to fruit flies to cyanobacteria, all tuned to 24-hour cycles of light and dark. Chronobiologists at Northwestern University documented in 2017 that these rhythms are genetically encoded, evolved over billions of years under a reliable sun. The genes for circadian clocks would remain in frozen DNA, instructions for responding to day and night that would never come again. Evolution had written the sun's rhythm into life's fundamental code, and that code would persist long after the rhythm stopped, a genetic memory of light. Space junk would slowly deorbit. Picture the thousands of defunct satellites, spent rocket stages, and debris fragments orbiting Earth, slowly spiraling inward. Orbital mechanics, calculated by ESA's Space Debris Office in 2018, show that objects in low Earth orbit experience drag from the outer atmosphere. Even frozen, even thinned, enough atmosphere would remain to gradually pull these objects down. Over centuries, the orbital lanes would slowly clear, debris burning up or crashing down until only satellites in the highest orbits remained. Earth would eventually have clean space around it again, not through our effort, but through patient physics. The last heartbeat would pump frozen blood. Consider a human heart, having beaten perhaps 2.5 billion times over a lifetime, attempting one final contraction as cells froze. Cardiologists at Johns Hopkins documented in 2017 how the heart continues beating briefly even in extreme conditions, the sinoatrial node firing electrical impulses automatically. That final beat would move blood perhaps millimeters before freezing stopped everything. Each chamber would contain blood frozen in mid-flow. Red cells arrested mid-tumble, a final snapshot of the body's hydraulic system caught between systole and diastole. To think that the rhythm that sustained us would end mid-measure, life's percussion stopped on a half note. Barchan dunes would freeze mid-migration. Picture crescent-shaped sand dunes in the Sahara or Gobi Desert, currently marching across landscapes at rates of 10 to 30 meters per year. Geomorphologists studying White Sands National Park documented in 2019 how these dunes migrate as wind moves sand grain by grain. Without wind, without warmth to create air circulation, the dunes would stop exactly where they stood. Some would be frozen mid-collision with others, their horns about to merge. The patterns that fluid dynamics creates would be preserved as solid sculpture, mathematics made visible in sand and ice.